Yeah, physics video. And to Hythloday mostly. I mean, he posted this FEYNMAN video, and yeah, sort of interesting. Okay, so yeah, it's the philosophy and probability of reflections. That's what it's called, but I don't know. Anyway, so here's the premise, or what he says, and you know, he says different things in different contexts, so I'll try not to put words in his mouth. But in this video, okay, he starts off, he just makes a fundamental mistake. Okay, so what he's basically, he's talking about reflection. So then there's water, and he basically says, look, you have light comes down, and he's saying 4% of the light is reflected. And then he says it's 2%. So right there you got a big mistake, right? Right in the beginning, he says 2%, then he says 4%. He seems to use the 4% more than he uses the 2% number, so we'll go with 4% being correct. And what he basically argues is that there's no point in figuring out what this looks like, you know, what the light looks like if it's shaped differently, and that's what's causing this percentage, and there's no point of looking it down here at the atoms and what they're doing, because this number is a function of quantum mechanics or quantum theory of some kind, probability, and that the probability is dictating this, not any of this dynamic. And you know, that's sort of a bogus argument. I think what he's really saying is, I'm really smart, I've thought about this, and I can't figure it out, so it can't be figured out. And that's what I think he's really just saying. He's just one of these arrogant physicists, sorry, but that's what it sounds like, who's basically saying, if I can't think of it, you can't think of it. You know, because he's basically saying, he did make the point, oh, well, they have thought of this and they have thought of that, and because they haven't thought of it yet, it means it must not exist, and it's some sort of magic, kind of. Anyway, that's the implications of what he's saying. So anyway, so this whole conversation just seems a little bogus in a lot of ways, because in the end of the video, in the question and answer part, oh, that's sort of inconvenient. No, I'm back. Distractions. No good for the brain. So anyway, so where we were is something like, okay, he makes this statement and then implies that there's something beyond our comprehensibility that's going on when this is happening. And so what he doesn't say is what's the difference between the depth of this water. So that's something he didn't deal with at all. And theoretically it could say, okay, if water is pure, you know, completely pure, that whatever phenomenon happens at this surface, that's what this reflection is a surface phenomenon. So as long as the water has a surface, 4% is going to interact with what the surface of the water is. And then theoretically, the rest of the light, the 96%, travels through the water freely, unless it hits something that's going to reflect light. So if there's something in the water, that will reflect a certain amount of light, or refract in a particular color light. And then obviously whatever's at the bottom would also affect how much light is going to be reflected back out. So if this was a mirrored surface, then obviously a lot of light would be reflected back out. So so I'm just saying his explanation was kind of weak, and the real argument is that, you know, he calls these probabilities, and the key word for him is this amplitude. So how strong is the probability, and this is all mathematically represented as vectors that you kind of add up. So, you know, if there were probabilities of a certain kind, then you would combine these points, and this would be your, you know, this balance between the two sides would be your overall probability. So you could add probabilities like you would add geometric objects in a way. And this sort of gets back to this whole argument about you know, circles and pi and all that stuff. You know, that they're, you know, I think pi is probably an incomplete representation of the formula for circumference, because you know what is a circle, but you know it's a geometry. So I don't think the circle is technically even really a circle. I mean, circles are geometry. And so you're really saying, okay, there's an area of a square which we don't have to worry about pi anymore. And then you know, then all we're doing is figuring out, well, what's the area of these little pieces here. You know, I mean, pi is about circumference, don't get me wrong, but area and circumference have a lot to do with each other. And so then you're just measuring different geometry, and you could split this geometry into geometry. And one could argue that on the smallest scale, a circle might well be just a polygon, because quanta themselves might have a length. And if theoretically, if you had a perfect circle and quanta had a length to them, there could be an absolute distance between the two lengths of quanta, and you could have such a thing as a perfect circle, but it would really be some sort of, you know, Google's on. I mean, you're really talking about it being, you know, square geometry, you know, like that kind of a thing, a sided object rather than a true circle. So you could almost say circle is probably better reduced to more standard geometry of triangles. And so then you're back to angles again. You know, the circle really is just you know, a radius of triangles. But whatever. Triangles with the same radius, or however you want to put that. Anyway, so back to this thing again. So I guess what I would argue, alright, is that, yeah, the water itself creates this 4% thing. So that, but that's a surface phenomenon. And surface, I don't mean that there's, you know, I don't think the water has some sort of flat, even surface. I mean, theoretically. It has, you could almost argue that all matter has structure in terms of how it relates to itself. Like many substances, water is not compressible. I mean, you can't compress water, and you can't compress more space out of it. So however the atoms are arranged, they're arranged rather rigidly. So you could almost argue that they might be in some sort of pattern, you know, even though they're made of simple substance, that their pattern is interlocking. Because otherwise you would be able to compress them. You'd be able to force them into a tighter pattern if there was some sort of theoretical space between them. Now, yes, an atom is made out of space theoretically, because you have this little thing circling, at least in the standard model, you have this little electron circling a nucleus, and you know, so that you'd say, okay, there's got to be some compressibility. And then, you know, with water, you have the, you know, you got the two hydrogens and then the one oxygen, and you know, the oxygen has lots of little electrons, but we'll just put them. So it's combined with these two high. Well, that doesn't look good. Yeah. Well, anyway, and obviously they have to relate to each other in some sort of pattern. So it's likely that the ones that are, the way they connect to each other is likely that the next atom of water connects, you know, in a space that's not filled by, you know, that space, and so on and so on. So there is a you know, a boundness to the structure that has a possible arrangement that's dependent on how many, you know, you can combine with each other, kind of a thing. They're, like, say the maximum number is 4. I think it's correct, but I'm not sure. But let's just say it's correct. So there's 4 ways, you know, there's 4 standard shapes, which would just be, you know, they connect at one side, or they connect at, you know, 2 sides, or they connect at all 4 sides, you know. So in terms of how they're bound, but obviously they're likely to be bound completely, especially at the surface. Well, maybe not at the surface, well, whatever. But I mean, the binding might be let me do it this way. Yeah, something like this. So they would be connecting, so the whole thing ends up getting filled with some sort of geometry. I mean, it's geometry in the end. It could be the standard model's correct, but I'm just saying it looks like geometry to me. And this one would go in here. I messed up the shape a little, but that's the general idea, is that this is not a compressible thing because it's already fairly rigid. And so the argument would be is that when the light comes in, it probably does have its own character, but in spite of that character, it's landing, it's hitting as it goes into the substance. It's going to not be hitting some sort of perfectly standard surface. It's going to be hitting a surface that is got a connected depth. And so as it comes in, some light's going to hit the hydrogen atoms, and then some light's going to hit the oxygen atoms. And so they're going to hit different atoms, and they're certainly going to hit in different spots and interact. And it's also the phenomenon called, the argument being made is that when this light comes in, it doesn't really reflect at all, and what it's actually doing is vibrating these atoms and causing them to release a new photon, technically, theoretically. But I think there is real, that's a tricky word. So yeah, that's really the argument, is whether you have whether you have such a thing as a real reflection, like is this photon comes in and this photon bounces off, or whether what's really happening is the photon goes in, the energy goes in, and the equal amount of energy goes out. The fact that it would go out in a similar angle is the tricky part to explain as a function of a refraction. A refraction being a consumption and then production of the light. Well, refraction is used for different things. It's used to describe distortions. So when you go between two surfaces and you get that effect where it looks like it's in a different place because the light has been distorted by the surface, and it's been bent. And so now the bent light is what you're seeing, and because of the bent, you see it like it came from a different location than its actual location. But anyway, I don't want to get into that crap. So I mean, the argument being made is that somehow this is a function, this 4% of that somehow doesn't have to do with the nature of the structure. I mean, he would argue that, say if I put these photons in one at a time and they all hit exactly the same location, that I could theoretically hit a spot that was a no percent spot, a 0% spot. And he's saying that's not necessarily possible. But I would argue that, he gave a Newton example of lenses, and the fact that this distance between two surfaces, so you take a lens on another surface, and that you have this distance between the two surfaces, and what it ends up creating is an optical pattern that's like the two-slit experiment in the sense that it's a banded pattern. So it's all on or all off. So somehow when the light comes in, it's forced to focus, essentially. And so anything coming in these spots would come out here as a double, and anything that hits these spots doesn't do anything. It just comes, there's a zero return. And so the explanation for that, so that the experiment to be done, I guess, is to hit this with single photons, spaced, and whether or not you could just keep pumping photons into some spot and never get any reflection back. It's probably correct. I have to think on that one. I mean, the energy obviously has to go somewhere. So no matter what's happening here, we know that this photon stuff is got energy in it. And so it's got to be, no matter where it goes. So in perfectly clear water, theoretically, 4% would be reflected off, and the other 96% would have to be absorbed by whatever the material is beneath the water. So no matter how deep the water is, if it's pure. So the real problem is like most water we're familiar with is dirty. So the water isn't got this perfect structure. There's blobs of other crap that are stuck in here that do create opportunity for not only compressibility but also opportunity for reflection. So that would change how much reflection there is based on how much of this crap there is. And that this crap could also create refraction, in the sense that this crap could absorb the light and then produce a photon going this way, or all kinds of different directions within the substance itself. So you get that a lot too with light. I mean, light comes into a piece of glass here, and you'll be able to see light come out the side of the glass there. So it's like the whatever you call that stuff, the glass fiber. Yeah, really, too early. I should have waited. Yeah, I can't believe I can't think of the name of it. Fiber optics. So yeah, that's the kind of the principle, is the light will, depending on how you have the glass manipulated, you can create a circumstance where it will contain light very efficiently. It'll move light from one place to another place with high efficiency, with no deterioration. And you can bend it and twist it and turn it and put it in a pretzel shape, and the light will do all of that funky movement through the material, which is a subject in itself, right? Just the very fact that you could take a stream of photons, to even think about light being capable of doing that. The light that we see is so linear, and to think that you could actually put the light inside of a pipe, and that you could bend the pipe any which way you wanted to, and the light would do just fine, going, spiraling, doing all kinds of funky, weird stuff out there, that you could just manipulate that light into any shape you wish to, without any friction, without any loss. That you can essentially do that. You can bend it for free. That there's no energy requirement for you to bend light. Light is bent without you having to create any mechanical force. You don't have to force it into a new configuration, a new direction. You can make it go in another direction without applying any force. And that's pretty interesting, I think. Yeah, it's really interesting, right? That you could theoretically make light do some incredibly bizarre things without any application of energy or influence. You don't have to influence it in some way besides the structure. So in a way, fiber optics are relying on some sort of perfect reflectivity. The light just keeps bouncing off the interior surfaces, and it there's no loss, or very low loss, through all those interactions with the surface. All those refractions cost it nothing. Nothing substantial. This isn't exactly where I wanted to go, but I think the point I wanted to make is that this is the irritating thing about these physicists, is they're just going to say, okay, it's 4%, and we're not going to bother dealing with how exactly the light is creating that 4%. They're just going to say, okay, it's 4%, and that's this probability. This is the wave function now, and why establish? Well, more illustrate over here as the wave function in terms of, but this refraction thing is more easily understood, because there's other examples of it. It's like you know, animals that can see really well in the dark. What they're basically doing is just having a more projected lens, and so what they're doing is, you know, just bending more light into a single focal plane. And so they're just taking, you know, the low light conditions, so they're just absorbing a larger surface area of light and focusing it on a smaller retina. And you know, so there's no magic there. Now I guess what I'm saying is there's no magic here. There's a reason why 4% is bouncing off the surface of water, and that it isn't traveling through water. It's a surface phenomenon. So it really has to do with the fact that the water probably has a surface that we don't see that's kind of like this, and that the fact is that surface, technically, that surface area, or whatever you want to call it, that layer, that initial layer, that boundary layer, has 4% of that boundary layer is likely to reflect the photon, and that the rest of the percentage of that boundary layer will let the light pass through unmolested. So it could just be that when this little nicker is small enough, the light's reflected. When it's any bigger than that, it passes through. And that little nicker would be another way of modeling the fact that the atoms themselves have an arrangement to each other, you know, that is semi-static. The water has a shape internally, a structure internally, and you can vibrate that shape, but that shape is functional, and it will always reestablish itself. So if I break the water, what's going to happen is it's going to reform the same sort of shape. It's going to inevitably take place in that it has inevitable functions. If there's an upward hydrogens over here, there can't be one right next to it. It can only reoccur in the fourth position. And in a sense, it has to reoccur in the fourth position because of what is preceding it. So no two, it's just basically saying that it's almost like electrical. You know, only a certain amount of negative can be next to a certain amount of positive, and only, you know, negative, positive. And that's the only way it's going to be able to establish structure. And so the argument is just basically because of the variety of shapes that this oxygen hydrogen molecule can establish in terms of connecting with itself, depending on how many shapes there are for that molecular construct, will dictate what percentage of light would reflect. So if you change the shape of this hydrogen molecule, you would change the percentage of the light that would be reflected. Seems obvious. And that any impurities in this substance would likewise change the reflexivity of the substance by breaking this surface continuity in places, and that you would lose that percentage because of that broken continuity. But that there is a continuity in pattern, that inevitably the pattern always ends up being some sort of A, C, F, G, H kind of pattern, just because of who can sit next to who. So it's almost like, you know, girl, boy, and then you have another set of arrangements that says, you know, shirtless and unshirtless, you know. So only a shirtless girl can sit next to a shirtless boy, or some kind of thing like that. So as soon as you add that extra variable, you force even more this pattern to always arise linearly, and so you're always going to be stuck with that probability of 4%, because this arrangement is always going to end up conforming to a pattern. Yeah, well, that's probably more than enough here. But yeah, it's not exactly what I want to get to, but I just want to get to the fact that it is annoying that these physicists talk as if not that these questions haven't been answered, like not that we haven't quite figured out a model that makes this make sense, but they almost are arguing that there is no model, that there is no way to understand the mechanism, that it just does this 4% thing, and it, even if it's exactly the same, you know, even if I make exactly the same circumstance and I just change one thing, I somehow won't change this 4%. And I think that's bullshit. And he says, okay, I know this doesn't make sense. He says that kind of shit. But trust me, it makes sense. No. I mean, it's just this, you know, I don't know why they all do this. I mean, they all seem to do this kind of crap. You know, this buying into this photon magic quantum wave duality bullshit. But they do, and you have to take that seriously. But I seriously don't think their explanation of their statement that this has been explored deeply enough, that the mechanical explanation has been already disproven or something, or that it's intrinsically paradoxical. And that really annoys me, is when they try that empirically paradoxical crap just because there's absolutes where math fails. I mean, obviously there's a circle so small that the two sides of the circle combine with each other, hit each other, and then yes, the math, all of a sudden pi's not going to work anymore. Duh. Because it's not a circle anymore. I mean, everything can be reduced into its into non-existence as a construction. And so that to say because math ultimately fails doesn't demonstrate that the math is failing. It's that reality fails. It fails to create something geometric. There's no longer any geometry. Yeah, something like that. So anyway, comments, and then I'll just take the next step with the comments, I suppose. So whatever comments there are, I'll try to interact with them in some kind of coherent way, and just see what my next, you know, I just find this very, I mean, I'm really just trying to figure out that what's more important, the function of the light or the function of the surface it hits. But the most important part is that we know light can be changed in its direction 360 degrees without any losses to friction, and that's really important, I think. That direction can be completely altered without without the influence of any non-static energy source. I mean, obviously the matter that light was interacting with has energy in it. Matter has energy in it. So there's obviously, light has to interact with something with energy in it. It has to interact with some kind of matter to have its direction changed. But the fact is, it can do that interaction it can do it being completely absorbed or completely frictionless. Yeah, that's the important one. Okay. Anyway, till next time. Such and so forth and whatnot.